The Theory of Political Economy by William Stanley Jevons. Chapter 7 Theory of Capital. Part 11 General Expression for the Rate of Interest. We may obtain any general expression for the rate of interest yielded by capital in any employment, provided that we may suppose the produce for the same amount of labor to vary as some continuous function of the time elapsing between the expenditure of the labor and the enjoyment of the result. Let the time in question be t, and the produce for the same amount of labor the function of t denoted by ft, which may be supposed always to increase with t. If we now extend the time to t plus delta t, the produce will be t plus delta t multiplied by f, and the increment of the produce t plus delta t multiplied by f minus ft, the ratio which this increment bears to the increment of investment of capital, will determine the rate of interest. Now, at the end of the time t, we might receive the product ft, and this is the amount of capital which remains invested when we extend the time by delta t. Hence the amount of increased investment of capital is delta t multiplied by ft, and dividing the increment of produce by this last expression we have t plus delta t multiplied by f minus ft over delta t multiplied by 1 over ft. When we reduce the magnitude of delta t infinitely, the limit of the first factor of the above expression is the differential coefficient of ft, so that we find the rate of interest to be represented by dft over dt multiplied by 1 over ft, or f prime t over ft. The interest of capital is, in other words, the rate of increase of the produce divided by the whole produce, but this is a quantity which must rapidly approach to zero, unless means can be found of continually maintaining the rate of increase. Unless a body moves with a rapidly increasing speed, the space it moves over in any unit of time must ultimately be inconsiderable, compared with the whole space passed over from the commencement. There is no reason to suppose that industry, generally speaking, is capable of returning any such vastly increasing produce from the greater application of capital. Every new machine or other great invention will usually require a fixation of capital for a certain average time, and may be capable of paying interest upon it. But when this average time is reached, it fails to afford a return to more prolonged investments. To take an instance, let us suppose that the produce of labor in some case is proportional to the interval of abstinence t. Then we have say ft equals a multiplied by t, in which a is an unknown constant. The differential coefficient f prime t is now a, and the rate of interest a over ft, or a over at, or 1 over t, or the rate of interest varies inversely as the time of the investment.